All right, so our reference angle for 225, so all the way around here is 225 degrees, but we want to find this part. Well, the distance to 180, our reference would be 45 degrees. And then we can find our coterminal angles. So we can take 225 and we can add 360. So we end up with 585. Or we can take 225 and subtract 360. So we have negative 135 degrees. 140, so that's in the second quadrant. So that distance to the x-axis, 40 degrees. So our reference would be 40 degrees. The coterminal, if we add 360, we're at 500 degrees. If we subtract 360, we're at negative 220 degrees. So now we're going to take a look. What are all of our angles that actually have a reference angle of 30? Because they can be in all the quadrants here. So what are these actual angles? We have 30 degrees. Well, if this is 180, 150 degrees. 30 degrees past 180 is 210. 30 degrees 360 less than 360 is 330. And now we can do the same for 60 degrees. We have 4 reference angles of 60. So we have 60 degrees. Let's see, 180 is over here, so that'd be 120. 60 below, we got 240. And then 60 over here, we have 300. And 45. So we have 45 degrees, 45 above, we have 135 degrees. 45 here, we have 225 degrees. And 45, we have 315. So the last thing we're going to do is we're going to review a little bit about triangles. So as a reminder, there's 180 degrees in a triangle. An isosceles triangle means if there's two sides the same, then our two angles, those base angles, are the same. And our Pythagorean theorem, a squared plus b squared equals c squared. So how would we find x here? Well, it's isosceles, so these two angles are both x. So if we do 180 minus 40 is 140. Well, they're the same, so they each have to be 70 degrees there. So x would equal 70 degrees. And then we have our Pythagorean theorem. So if we set this up, 6.3 squared plus x squared equals 15.4 squared. Solve for x. So we have x squared equals 15.4 squared minus 6.3 squared. And I did that already, so we got 197.47. Square root each side, and you guys can see we end up with approximately 14.